So what we're going to talk about is all of these vocabulary terms. And you'll notice I already printed or typed all this out for you. So you don't have to worry about copying this over into your notebook. This is all of the vocabulary we're going to talk about during these two examples, and also how we would find these key features. So in this part of our quadratics unit, what we're doing is looking at these graphs and talking about the key features that we looked at back in Unit 1. But now that we're talking about quadratics, there are some specific things that we are going to add to this puzzle. So what I'm going to do first is I have this already graphed in Desmos. You get to use Desmos this entire part of Unit 4. So I already have it typed in here. I'm going to minimize that side so we can see the whole thing. This is called a parabola. It's that U shape. It may also look like a hill because it could possibly be upside down. I'm going to zoom out just a little bit so that you can see no matter how far I zoom out, it's still maintaining that U shape. So I'm going to zoom back in so we have a little bit of a better view here. I'm going to get rid of those. With parabolas, they always are going to have either a minimum or a maximum. In this case, I have a minimum. This parabola, we would call it opening up, which creates that U or that smile shape. In a question like this, if I think about possible x values that I could put in for my domain, there is no value for x that I would ever substitute into this problem and not get an output value. So that tells me that my domain is every possible x value in the whole universe that we could ever think about. There's a few different ways we could write that. If you remember our interval notation back from Unit 1, I could write negative infinity is less than x is less than infinity. We could also write all real numbers. And I'm going to use my shorthand. But these are two possible options for how I could write the domain. Now, when we talk about range, I'm talking about y values. Well, since I have a minimum, it's this point right here. That is the lowest point I could ever get to on my graph. I care about the y value of -4 because that is the lowest point I will ever get to. So the way we're going to write that is y is greater than or equal to -4. You could also see that written as -4 is less than or equal to y is less than infinity. Both of these mean the exact same thing. This one shows that it's going to infinity very explicitly. This one is just implied that it's all y values that are bigger than -4. There's never going to be a place where this stops. X-intercepts, we talked about those in the end of our last part of Unit 4. The x-intercepts are also where we find our zeros or our roots. And the greatest part about Desmos is all I have to do is click and it will tell me the exact coordinates. So I am going to write that my x-intercepts are -3, 0, and 1, 0. And while I have Desmos open at the moment, I'm also going to come down here and look at my y-intercept. So my y-intercept is 0, -3. So those are our key features so far. The vertex and the axis of symmetry is new, and these are very specific to quadratics because the beautiful thing about a parabola is it is perfectly symmetrical around this imaginary axis of symmetry. There is an imaginary vertical line here that cuts my graph right in half. And what I'm going to do is I'm actually going to use Desmos to show you this. So this point down here, it's a minimum, and we call this our vertex. That is the turning point from, in our case, decreasing to increasing. It's the lowest point I will ever see on my parabola. And if you'll notice, that had an x value of -1. So what I'm going to do is actually graph that x equals -1. And you'll notice that this blue line is cutting my parabola exactly in half. And if I continue to zoom out, you'll notice that that blue line, which is our axis of symmetry, is always right down the middle. It cuts our graph directly in half. So I'm going to zoom back in again. So our axis of symmetry is that imaginary vertical line that cuts our graph directly in half. And exactly how I wrote it in here to graph, x equals -1, is exactly how I write my axis of symmetry. It happens at x equals -1. And then our vertex was -1, -4. And I want to just point something out to you about your axis of symmetry and the x-intercepts. These will always be, because of what the axis of symmetry does to our parabola, these will always be the same distance from the axis of symmetry. So here I would have to go over 1, 2 points to get to this one. Same thing here, I'm at -1, I would go over 1, 2. So this will always be exactly halfway between any 2 points that have the same y value. The last thing that we need to look at is our increasing and decreasing intervals. This goes back to, actually I'm going to leave that axis of symmetry in here just to help our brains. This goes back to Unit 1, way back in January. So I'm always moving from left to right as I read my graph. So the first thing that's happening here as I move from left to right is my graph is going down, and it stops decreasing at the vertex. So for all of my x values that are less than -1, I'm decreasing. And on the flip side of that, quite literally, as soon as I flip to the other side of the vertex, I am now increasing. So I would write this as any x value greater than -1, we are increasing. The only time I will ever write an interval using a y value is the range. All of my other intervals and axis of symmetry statements are all going to be x values every single time. So I'm just going to move my camera down a little bit so we can look at example number 2. Now with example 2, I did give you a table because we do need to be comfortable looking at tables and at graphs. So the first thing that I do when I'm looking at a table is I need to double check and make sure this actually is a quadratic function and represents a parabola. And the way I'm going to do that is I'm going to look at my y values. These are going down first, and then they start going back up. And I also see that these y values begin to repeat, and they repeat around this point right here, 1, -4. And since that's where we're starting to see that repetition of y values, that tells me that this point right here is my vertex. So if I were to graph this on a coordinate plane, this would be a minimum, just like on our last example, because these values are higher than -4. So -4 is the lowest value that we ever get to. So that tells me, in this case, it just so happens to have the exact same range as the question we did before. So also talking about this lowest point, I can also find the axis of symmetry from here because it's the x value of the vertex. And the range will also come from the vertex, but the range will come from the y value of the vertex. Let's do x-intercepts now. So x-intercepts occur when the y value is 0. So I see here y values of 0. So that tells me that these two things are my x-intercepts. So I have -1, 0, and 3, 0. And then if I want to find a y-intercept, I look for where x is 0. So my y-intercept would be 0, -3. We are going to assume, because it was not explicitly stated, we're going to just assume that this is a continuous function. So I'm going to put all real numbers here for my domain. It's very, very rare that we will deal with a quadratic that is discrete, which is when it's just a continuation of different points. So I'm going to wave my magic math wand and say that this is continuous instead of discrete. Then the last thing we need to do is write our increasing and decreasing intervals. These are going to occur around the axis of symmetry or the vertex. So if I'm dealing with a table, I actually draw myself a little horizontal line in my table where the axis of symmetry is occurring so that I know one side is decreasing and the other side is increasing, and I just have to figure out which is which. So as I'm going down my table and my x values are getting bigger, which would mean I'm moving from left to right on my graph, here my y values are getting smaller. So that tells me that's my decreasing interval, because as x is going up, y is going down. So then I would have x is less than 1 because it's all of my x values that are smaller than 1. So if I look on the other side of that, I go from -4 to -3 to 0. So as these x values are going up, the y values are going up. So that would be my increasing interval.